17. F equals x to the n, where n is a positive integer. Oh, we did a problem like this before. Oh man, you guys want me to take away this problem? Now, guys, this is calculus, you know. Calculus, the hardest thing about calculus is not going to be doing the calculus. It's going to be reading the dumb calculus problems, okay? So what is this problem saying, and then how can we go about solving it? Okay, well, it's saying that n is a positive integer. So it's not a variable, it's a number, okay? So this is some number. So let's like say we have x to the second power, all right, or x to the third power, or x to the fourth power, all right? It's one of these numbers. It says it's an integer greater than or equal to 2, so all of these are possibilities. Integers means it's not a decimal, okay? All right, so let's read now. It says the graph of f of x will have an inflection point when n, okay, when will the graph, which is f, when will f have an inflection point? Well, let's think about this for a second, okay? I'll go back to my little picture right here. The graph of this would be a parabola. The graph of this would be like the flattened out end kind of thing. And the graph of this would be a parabola again, but kind of stretched out. And then if I go to the next integer, that would be back to the end looking thing. Okay, and the only way you would know all this stuff, guys, is if you know about polynomials, if you've graphed polynomials, if you spend a lot of time doing that. Okay, you know that if you have even exponents, then they're going to be pointing in the same direction for the n values, the n behaviors. If you have odd exponents, then you're going to be pointing in different directions for the n behaviors. Okay, you guys remember that word, n behaviors? Okay, now concavity, what the heck is that? Well, right here, this curve right here, the concavity is concaving up the whole time. You only get inflection points when concavity changes. Check out the next one. It's concaving down, and then we're concaving up. And so that means right here, we have a point of inflection. Whenever you have a point of whenever you have a point where the concavity changes, that's a point of inflection. We do not have one right here for the x to the fourth because we're concaving up the whole time. And for this one, we're concaving down, then concaving up, so boom. I hope you guys see the pattern. So let's read the question again. It says, the graph of f will have an inflection point when n is what? Even, odd, divisible by 3 for all values or for no values. Hopefully you were thinking odd, and that's your answer.